Step 2 in risk assessment, vulnerability identification. Vulnerability is a flaw or weakness in system security procedures, design, implementation, or internal controls that could be exercised, accidentally triggered, or intentionally exploited, and result in a security breach or violation of the system security policy. Vulnerabilities can be identified by numerous means. Different risk management schemes often offer different methodologies for identifying vulnerabilities. In general, start with the commonly available vulnerability list or control areas. Then working with the system owners or other individuals with knowledge of the system or organization. Start to identify the vulnerabilities that apply to the system. Specific vulnerabilities can be found by reviewing vendor websites and public vulnerability archives, such as NIST ICAD Vulnerability Database, National Vulnerability Database, NVD, Common Vulnerabilities and Exposures, CVE, Commercial Computer Incident, Emergency Response Teams, and Post List, such as SecurityFocus.com forum mailing list. If they exist, previous risk assessment and audit reports are the best place to start. Security system testing method, such as automated vulnerability scanning tools, security test and evaluation, and penetration testing. These are all powerful methods in uncovering vulnerabilities in a practical manner. A security requirement checklist is another method in identifying vulnerabilities. Contains the basic security standards that can be used to systematically evaluate and identify the vulnerabilities of the asset, such as personnel, hardware, software, and information. There are 3 categories of a security requirement checklist. First is management-related checklists, such as continuity of support, incident response capability, assignment of responsibilities, and risk assessment. Second, operational-related checklists, like facility protection, workstation, laptops, external data distribution, and labeling. Technical checklists, such as cryptography, discretionary access control, identification, authentication, and intrusion detection. It is invaluable to have a base list of vulnerabilities that are always considered during every risk assessment in the organization. This practice ensures at least a minimal level of consistency between risk assessments. Moreover, vulnerabilities discovered during past assessment of the system should be included in all future assessments. Doing this allows management to understand that the past risk management activities have been effective. One of the more difficult activities in the risk management process is to relate a threat to a vulnerability. Nonetheless, establishing this relationship is a mandatory activity, since risk is defined as the exercise of a threat against a vulnerability. This is often called threat-vulnerability TV pairing. Once again, there are many techniques to perform this task. Not every threat action or threat can be exercised against every vulnerability. For instance, a threat of flood obviously applies to the vulnerability of lack of contingency planning, but not to a vulnerability of failure to change default authentications. Well, logically, it seems that a standard set of TV pairs would be widely available and used. Currently, that's not the case. This may be due to the fact that the threats and especially vulnerabilities are constantly being discovered, and that TV pairs would be changed fairly often. Nonetheless, an organization standard list of TV pairs should be established and used as a baseline. Developing the TV pair list is accomplished by reviewing the vulnerability list and pairing a vulnerability with every threat that applies. Then by reviewing the threat list and ensuring that all the vulnerabilities that the threat action or threat can act against has been identified. For each system, the standard TV pair list should be tailored. This table shows 3 pairs. First, terminated employee system ID are not removed from the system. The terminated employee or actor dialing into the company's network and accessing company proprietary data. Second, company firewall allows inbound telnet, and guest ID is enabled on XYZ server. Unauthorized users such as hackers, computer criminals, and terrorists use the telnet to XYZ server and browsing system files with the guest ID. The third, the vendor was identify flaws in the security design of the system. However, new patches have not been applied. Unauthorized users obtaining unauthorized access to sensitive system files based on the known system vulnerability.